Hello, dear student. Myself Arif Khan Pathan, and welcome back in the third part of this antiseptic and disinfectant. Previous example we had seen, and now the next example we are going to see, which is a phenol and related derivative, that is chloroxylenol. We know that Dettol is the most popular antiseptic which is available in the market, and the Dettol contain an active ingredient, that is chloroxylenol. Means chloroxylenol is available in the market in the form of Dettol solution, Dettol soap, Dettol sanitizer, as well as Dettol hand wash. These all are the formulation which is the most popular and which contain chloroxylenol. So as far as the physical property of chloroxylenol is concerned, it is a white characteristic odor, taste again a characteristic crystalline powder, and insoluble in water. That's why we are normally, when we are going to see the solution of Dettol, it will be in alcohol because it is insoluble in water. Next stability storage condition is as well that it should be stored in tightly closed light resistance container. Now as far as the uses are concerned, it is used as antiseptic for cut, wound and abrasions. We know that normally we are applying the Dettol on wounds wherever there is an injury. So in that case it is applied as antiseptic. That's why the chloroxylenols having the first use, that it is an antiseptic for cuts, wounds and abrasions. Next, as a disinfectant, again same, the Dettol solution we will use to disinfect the utensils as well as the some non-living objects or floorings, or sometime maybe the equipments, which to make it free from microbes. And we as we are applying this Dettol solution on non-living things, that's why it may be acting as a disinfectant. So in both the way, it is acting on living tissues, antiseptic on non-living inanimate objects, in that disinfectants. Next formulations are chloroxylenol solution. Again their hand wash is there, soap is there, various formulations are there. Next brand names are Ferginol and Dettol. Next aldehyde. So this belongs to the chemical class aldehyde. That actually the formaldehyde is the best example, suitable example. Aldehyde that we are going to see, formaldehyde solution. First one carbon containing aldehyde, the first member from this aldehyde family, that is formaldehyde, and that is acting as antiseptic and disinfectant. So now what is this formaldehyde solution? It is an aqueous solution containing 36% weight by weight of formaldehyde. That is 36% weight by weight of formaldehyde, that in a particular solvent, in order to prepare its formaldehyde solution. Physical properties: colorless, characteristic, irritating, has irritating odor as well as irritating taste and burning taste. When we are going to taste, it will be showing burning sensation, and obviously it is a liquid in nature. So this is the most important thing, that it is not a crystalline solid, it's a liquid. So we must have to categorize this drug into the liquid one. Next, chemical properties, in that first the polymerization. So this showing polymerization in that first, when formaldehyde solution is treated with 2% sulfuric acid, the vapors are condensed. When we are treating with 2% sulfuric acid, there is a formation of vapors, and these vapors are to be condensed quickly, or collect quickly and condense quickly, and there is a formation of trioxane, or that is also called as trimethyl trioxymethylene is formed. You can see in the structure, three molecules of formaldehyde, 3HCHO, that is three molecules of formaldehyde, get polymerized or get linked together or get cyclized, and there is a formation of trimer. From three molecules there is a formation of trimer, and that is called as trioxane, or it is also called as trioxymethylene. So three molecules, trioxane, and this is called as trimerization, we can say that, or there is a polymerization, but three molecules, trimers is being forming. First example, that is of polymerization. Next, when formaldehyde solution is evaporated, to evaporate, a white friable mass of polyformaldehyde is obtained. In this case, n number of formaldehyde get converted into its polymer, that we call a polyformaldehyde, and this is exactly we can call a polymerization, because n number of molecules get formed and exactly the polymer is being forming, and the polymer we are calling polyformaldehyde. Next chemical reaction, which is important one, because the product whichever forming it, that is useful. So when reaction with ammonia, when formaldehyde solution is treated with the ammonia solution, it is converted into hexamine, or is also called as urotropin. So let us see the reaction. The formaldehyde HCHO6 molecule with this ammonia, so it will form this called as a hexamine. This is called as hexamine, or also called as urotropin. So now this urotropin acting as antiseptic, mostly that is acting as urinary antiseptic. So chemically it is hexamine, but it is also called as urotropin because urinary antiseptic. From urinary antiseptic, this hexamine acting as urinary antiseptic because it is made up of formaldehyde, and formaldehyde itself an antiseptic disinfectant. So it is in the form of say hexamer called as hexamine, and that is urotropin because when it is reached to the urinary tract, it is subjected to release the number of molecules of formaldehyde, and that is showing their effect and acting as a urinary antiseptic. So hexamine is important one. We'll see what's the property associated with the hexamine. Hexamine is acidic in acidic medium. When the urine becomes acidic, it undergoes a decomposition and it gives the formaldehyde. Means whatever it is of made up, it's made up of 6 molecules of formaldehyde, hexamine, urotropin. So that will releases the 6 molecules of formaldehyde over there, wherever there is an acidic media in a urinary tract. So therefore hexamine is used as urinary antiseptic when given in combination with the acidifying agent. We have to make the urine acidify so that these hexamine or urotropin will get decomposed and will again reconvert into with which it is made up of, that is the formaldehyde, and it releases the 6 molecules of formaldehyde, and that formaldehyde acting as antiseptic to prevent the infection in urinary tract or urinary antiseptic. Next, Canizaro's reaction is the least important. Former two chemical reactions was important one. Next, stability storage condition. It should be stored in tightly closed light resistance container, moderately warm place. Contact with rubber and plastic or polythene to be avoided, because in presence of formaldehyde, or formaldehyde will get liquefied these types of closures, and that leads to a leakage in the sealed container. That's why we have to avoid the use of these rubber or plastic or polythene closures to the containers, because it may subjected to melt out, and that results in leakage of the bottle or container. Next, use as powerful, as I told, formaldehyde used as powerful antibacterial agent. It is used in the treatment of chronic bacterial disease. Third, use that as an antiseptic in the form of mouthwashes and gargles. Will be applicable as a disinfectant to disinfect the rooms. Normally formalin solutions are available, or some of these disinfectants are available for the cleansing of the floors in hospitals as well as in laboratories, to disinfect the rooms, instruments and clothings, or maybe the handles of some of the equipments, or maybe in the handles of particularly in the buses, transport vehicle, or like cupboards and all these. If you want to sanitize this handle, we have to use this disinfectant. And at the site of operation, and particularly in the renal dialysis, what are the unit is used, or what are the equipments are used to be disinfect first before the blood transfusion or before this renal dialysis. Next use is as a protein precipitant and causing astringent effect and killing the bacteria. Next, as a preservative for pathological specimen. We know that the specimens like heart or kidneys, these specimen tissues are being preserved in museum. So they are deep, we can see that they are deep in some other solution, and that solution is the formalin solution, that we calling a that is also called as formaldehyde solution, formalin solution, in which that is acting as preservative, which can preserve the sample pathological biological or pathological specimen or samples for long period of time. Hexamine is used as urinary antiseptic. We already discussed in combination with the acidifying agent. Acidifying agent, normally we have to use the ammonium chloride injections that we are using as acidifying agent to make the urine acidic, so that the hexamine can release the formaldehyde when the urine become acidic, and that is acting as an antiseptic. Pharmaceutical formulation, formaldehyde solution, gel, and the popular brand that is Canapib. Next, hexachlorophene. Hexachlorophene is a white, odorless, light phenolic odor. It has a characteristic taste, crystalline powder, insoluble in water, similar as that of the hexachlorophyll. Next, chemical properties. When it is treated with the sodium hydroxide, it is converted into a monosodium derivative. Normally, the name of the antiseptic, that is actually the hexachlorophene or hexachlorophane. So it indicates that there is a hexachloro. 6 chlorine, you can see in its structure. There is a 6 chlorine. That's why the chemical name become hexachloro, and basically it is a phenol and related derivative. So phenol, basically phenol with trichloro, second phenol with trichloro, it become hexachloro. Both are bridged together by carbon bridge, and this we call a bridge structure also, but not heterocyclic. Next, stability storage condition of the hexachlorophene is it should be stored in tightly closed light resistance container. Uses as reduce the bacterial flora from the skin. It reduces the bacterial infection on the umbilical cord, particularly for newborns or the infants. When umbilical cord got cut out, it should be used these types of antiseptic to prevent the sepsis. Next, disinfectant of the hands of surgeon, pharmaceutical formulation, concentrated solution of the hexachlorophane, dusting powder is available, again a mixture is available, and the cleansing emulsion is available. Stirac and Zalpone, these two are the brands for antiseptic hexachlorophene. And this is the last antiseptic that we are categorizing into the urinary antiseptic in the miscellaneous class, nitrofurantoin. Physical property of nitrofurantoin is yellow, odorless, and has a bitter taste. Stability storage condition of nitrofurantoin. So it should be stored in tightly closed light resistance container. As usual, storage condition is there. Then uses as a broad spectrum antibacterial agent in the treatment of urinary tract infection. Pharmaceutical formulations are nitrofurantoin suspension and the capsule and a tablet. Next, the brands are furadantine. Furadantine as a form of oral suspension, it is available, as well as the tablet again available, furadantine. So thank you so much. That was the last antiseptic and disinfective agents. Here we have finished the topic. Finished that. This was the last part from the antiseptic and disinfectant. Thank you. Thank you for your patient listening, and thank you for your watching. Thank you so much.